Let's look at some examples of solving logarithmic equations. For example, let's solve this equation for x. We can begin by bringing the 8 to the right-hand side, which would give us that log base 5 of x plus 4 is equal to 9 minus 8, or 1. And now writing this in exponential form gives us that 5 raised to the first power is equal to x plus 4. Because remember that log base a of x is equal to y is equivalent to the exponential form a to the y is equal to x, which is what we used here. And now if we subtract 4 from both sides, we get that x is equal to 5 minus 4, or 1. Now in solving logarithmic equations, it's very important for us to check our answers. So let's do that. Let's check that this value, x equal to 1, satisfies this equation. Namely, is 8 plus log base 5 of 1 plus 4 equal to 9? Or is 8 plus log base 5 of 5 equal to 9? And it is, because log base 5 of 5 is 1, and 8 plus 1 is 9. So yes, it works. Therefore, our answer is x is equal to 1. All right, let's see another example. Let's solve this equation for x. Now we can begin here by condensing the left-hand side into a single logarithm by using the following property. The log of a plus the log of b is equal to the log of the product, a times b. That is, this equation is equivalent to log of x minus 15 times x is equal to 2. And now we can convert this into exponential form again by using this equivalence here. And remembering, though, that log means log base 10. That is, this equation is equivalent to 10 raised to the second power is equal to x minus 15 times x. Or 100 is equal to, and now distributing our x, we have x squared minus 15x. And bringing all the terms to one side gives us that x squared minus 15x minus 100 is equal to 0. And now let's factor the left-hand side. It factors into x minus 20 times x plus 5. And now we have a product of factors equal to 0, which means either the first factor is 0 or the second factor is 0. When the first factor is 0, that means x is equal to 20. And when the second factor is 0, that means x is equal to negative 5. But remember, we have to check these answers. So let's start with x equal to 20. We'll plug it in here and here. So the question is log of 20 minus 15, which is 5, plus the log of 20 equal to 2. Again, we can use this property. So the question is the log of 5 times 20, or log of 100, equal to 2? And it is, because remember, log means log base 10, and 10 squared is indeed 100. So x equal to 20 works. It is a solution. What about x equal to negative 5? Well, that would require us to plug in a negative 5 here as well as here. which we can't do, right? Because log of negative 5 minus 15, which is log of negative 20, and log of negative 5 are both undefined. Because remember that the domain of the logarithm is values that are strictly greater than 0, which means we're going to cross off x equal to negative 5 over here. And therefore, our only answer is x equal to 20. So it's very important to check your answers when solving logarithmic equations. Thank you, and we'll see you next time.